Hello everyone, and welcome to the first video on simple calculus mistakes. These are a few of the most common calculus mistakes that beginning students can make, from beginners all the way up to, I dare say advanced, but all the way up to the intermediate stage, more or less. These mistakes, doesn't mean that you don't really understand the material. Sometimes, we just have vices, that little areas in certain subjects that we just can't quite break. But I hope that this helps. And the first one I want to talk about is involving integration. One of the most common mistakes would be the integral of just a number, say 2 dx. A lot of students want to apply the power rule of integration, which would be to add 1 to the existing power, so that would be 2 squared, and then put the new power in the denominator, right? Well, that's incorrect, and then they would want to do 4 over 2 equals 2 plus c. Well, that's the incorrect solution. What you want to think of when you see this kind of problem is, what are you taking the derivative with respect, or the integral, with respect to? Well, dx. But the problem comes in, there's no x here. So what do you need to do to complete this? It's just 2x plus c. That's the solution. You tacked on an x because there is no x behind this 2 to begin with. So you couldn't take the power rule because there was no x there. So now you got your x and your c. The c is very important. This is a whole nother discussion in and of itself, because when you get to differential equations and higher maths, not tacking on your c will get you in deep trouble, because you solve for c in differential equations and others. So this is our solution to this common mistake. Now the next common mistake would be something like dy by dx of 2. We'll use the same number, the same integer for this problem. The solution to this is just 0, because you have nothing, you have no constant to apply to this 2, so 0. A lot of students will also want to use the power rule of derivatives to this, and come up with some funky solution that isn't relevant to this. So 0 for taking the derivative of any integer by itself without respect to anything. Now there's a funny story that I can tell you about this problem right here, the derivative problem. Back when I was taking Calculus 3, one of my instructors came in after a really tough test on the next class lecture, and was really disappointed with us. And he said, some of y'all need to go back to the drawing board and learn the most basic fundamentals of calculus. I know you've got great minds, you have the ability and the capacity to learn these things. You have intelligence, you have the capability to learn, but you just don't, you're not incorporating the most basic fundamentals. These would be a few of these basic fundamentals that often those students missed in my class, in that particular calculus course. They understood how to do the Green's theorem, and they understood how to take triple integrals, and they could do far more complex integration and derivation than this, but they were stumped on the most simple things, and that's oftentimes how it goes with really intelligent people sometimes. But anyway, these are two of the most common problems. My instructor walked in, and basically he said, the next time I see you walking down the hall and I ask you what time it is, your response to me will be, the derivative is. And of course the derivative of any time is just going to be a number. It's going to be 0. That's the point he was making, is he wanted us to get to recognize these two different solutions that for some reason were hard to come by that semester. Thanks a lot for watching. I hope this helps.